Welcome back, Grade 6, to Nelson Math, Chapter 7, Getting Started. 2D Geometry, two-dimensional geometry. In this unit, we are going to be able to describe properties of triangles and quadrilaterals. Triangles with three sides, quadrilaterals from the Latin for four, they have four sides. We will construct polygons using measurement tools. Sort polygons according to line symmetry and other properties. Communicate about polygons. So today, as always, we're going to start with our review of previous terms and ideas. So we are going to be looking at these triangles right here and classifying them first by angle measurement, the size of the angles, and then by the lengths of their sides. We're going to be using the following words: obtuse, right, acute, equilateral, isosceles, and scalene. For A, all of the sides are exactly the same length. We measured them, so that makes it a triangle that has equal length sides. In other words, equilateral. Equi for the word meaning equal, and lateral meaning sides. So we know that this has all equal sides. They're all the same. If all the sides are the same, it means all of the angles must be the same. So because all of the angles are less than 90 degrees, we can tell that visually, it must be an acute triangle. So if we're going to classify by angle measurement, it's an acute triangle. If we're going to classify by side lengths, it is equilateral. Let's go to B. We can see from these measurements, this is one right angle right here. That makes it a right angle triangle. And we also know that the three side lengths are all different. That makes it a scalene triangle as well. The side lengths are different, which then means all the angle lengths are different. Let's look at C up here. We measured this angle here. This angle up here at the top is definitely more than 90 degrees. That means the angle is obtuse. Acute angle means that the angle is less than 90. Obtuse means that it is more than 90 degrees, but less than 180 degrees. And this angle here falls into that measurement. However, these two sides are the same length, the side on the left and the side on the right. That makes it an isosceles triangle based on side measurements. So this triangle here is both an obtuse triangle and an isosceles triangle. Lastly, here's D. Even though this angle down here looks like it is 90 degrees, it's actually a little bit less. And you'll see that if you measure it. But this angle here is slightly less. Because this angle is slightly less than 90, this angle is slightly less than 90, and this angle is slightly less than 90. By angle measurements, it is an acute triangle. If all three angles are different, then all three side lengths must be different, even without measuring. But we can go ahead and measure and see that these three side lengths are different lengths. So this makes it a scalene. Let's go on to the next question. It's asking us to construct a triangle with a 73-degree angle between two sides with lengths of 3 centimeters and 5 centimeters. For the purposes of number 2, I am going to be using a ruler, and this is a centimeter and inch ruler. We're going to be using the centimeter ruler. And right here we have our protractor to use the measurement for the angles. So to start, I'm going to make two lines. One will be 3 centimeters, one will be 5 centimeters. I'm going to use my tools here for the software that I've got. Here's our first line. The 0 is right here. So here's our first line of 3 centimeters. I'll format that a little bit so that it's a bit darker. That makes it good and visible. So here's one line of 3 centimeters. And I'm going to make another line of 5 centimeters. right there. So here's my 3 centimeter line. Here's my 5 centimeter line. This is asking me now to organize these in such a way where I somehow have a 73-degree angle. I can estimate this, but because we have a protractor, I'm going to be making it exactly correct. So this line here is moving on me. I'll have to measure it later. So to start, I'll just extend this line upwards. To start, I'm going to need to measure exactly a 73-degree angle. Let's move all this down a little bit. So I'll move this down to make it easier to see. And you can tell that I'm putting my 5 centimeter line right on this thin black line that runs along the bottom, not the bottom of the plastic. This thin black line that runs along the bottom of the protractor. The plastic is extra in case it gets snipped off or trimmed somehow by accident. So right here you can see I have my black line exactly, get it even more exact there, right there. I have my black line exactly where the black line of the protractor is. It's asking for a 73-degree angle. Because we're starting from this side on 0, we're going to use the inner scale. So the inner scale, if I put the corner right on the corner, right now it's at about a 50-degree angle. I don't want a 50 degree, I want 73. So there's 60, there's 70, and 73, this is 75, 73 is right there. So I have a 73-degree angle. So now I'm going to use my ruler and I'm going to make this measure and make exactly a 5 centimeter line. So I believe this one was 3 actually, so it'll be a 3 centimeter line. So just bring this right down to 3 like that. So we've just measured, here we have a 5 centimeter line, a 3 centimeter line, and this angle here is 73. I'm going to just lock the two of them together by going to group. This way, whatever I do, they're not going to fly away or anything. So let's try this again. If I measured it, I can see that this is still a 5 centimeter line right there. So our numbers are still good. But now I have to make one more line reaching from here to here. So I'm making my third side and I'll make it a bit weightier. And there's our triangle. So we just made a triangle that has a 73-degree angle and a 3 centimeter line and a 5 centimeter line. Number 3, identify each angle in this polygon as acute, obtuse, right, or straight. We can eliminate straight right away. A straight angle would be a 180-degree angle. So if I look at this, for example, this thin black line that runs across, that's a 180-degree angle. That's why our scales go from 0 to 180 and 0 on this side to 180. So none of these is going to be a straight angle, except for D. I just realized we have D there. So D is in fact a straight angle right there. D is a straight angle. E is a right angle. It's a 90-degree, so it's a right angle. A and B are both acute. A is less than 90, B is less than 90 degrees, and C is obtuse. If this is a 90-degree angle, we can see this angle opens up much wider than the 90. So that makes C obtuse. To pay extra special attention to D here, we don't normally think of as a straight angle like this as an angle, but it is in fact definitely an angle, and the measurement is 180 degrees. We can check that. I'm just going to bring this to the front. We can check that by taking our protractor, and if I can spin it around just right, I can see when I put this down right over top of the D, it's a straight line. So in fact, it is a 180-degree angle. And that's our review of triangles, angles, and side lengths, and quadrilaterals. Thanks, everyone.